Another pretty common cure for infection prior to antibiotics was the use of heavy metals. Mercury, for example, was used to treat lots of different diseases. And it actually worked because mercury kills bacteria. Also kills our cells, but that's fine. And so here, this is mercurochrome. I don't know if you can read this. It's not terribly clear. It's kind of a blurry image, but this is Johnson & Johnson. So, this was still being marketed in the 18 and 1900s in the US. Mercury was pretty useful against syphilis as far back as the 1500s. It was also used to treat typhoid, parasite infections. If you had a skin infection, they would turn it into an ointment called quicksilver. Now, the problem with mercury, like I said, it's toxic to microorganisms. It's also toxic to people, and it tends to affect the brain. So this is the Mad Hatter from Disney's Alice in Wonderland, which is based on a book. And hatters, people who made hats, used mercury in the hat making process, and sometimes they were a little bit cuckoo. And so that's where the saying mad as a hatter came from. So mercury could also affect the brain. Chemotherapy is the idea of using chemicals to treat any sort of disease. We typically use chemotherapy now when we talk about the treatment that patients use for cancer. But again, using chemicals to treat any sort of disease is technically chemotherapy. So Paul Ehrlich in the late 1800s and early 1900s, he came up with some chemotherapies for infection, and he used the term magic bullet. The idea behind the magic bullet is you want to be able to kill the infection, but not kill the patient. So that's why mercury, maybe not great. Too much mercury could kill the patient. Sure, you'd kill the infection, but the patient dies too. So you want that magic bullet of something that targets the infection but doesn't hurt the patient. And so his lab developed an organoarsenic. So it's a arsenic derivative, which of course sounds scary, but bear with me, which they found had really potent effects against syphilis, and also a disease called sleeping sickness. So sleeping sickness is a disease that is typically found in Africa. It's a parasite. It's transmitted by a type of biting fly. We have a very closely related parasite in the Americas, not as common in the US, but in Central and South America, called Chagas disease, and it's transmitted by kissing bugs. So this idea that it could work against that parasite and syphilis was really great. Now, as you might imagine, with a name like organoarsenic, there were strong side effects, but they tended to see that it actually did get rid of the infection without killing the host. Maybe you didn't feel so good, but you didn't die, so that's good. It was unstable until it was dissolved in water, so you couldn't just carry a powder around. It would kind of fall apart. But he also found that if you used the same dyes that you would use in the lab to stain bacteria, that would kill them. So one of the things about working in a microbiology lab, even though we have microscopes now, we have a lot more technology than previously, bacteria are still hard to see in a lab setting. So often what we do if we want to look at bacteria under a microscope is we use a dye to stain the cell, because they don't really have color. The cells are colorless, and so it's really hard to see them. But if you stain them with the dye, then you can see them and you can see their shape and everything. And so one of the really common dyes that we use, just as a very basic dye to stain the cells, is called methylene blue. And because methylene blue also has an effect of killing microorganisms, Ehrlich decided to use methylene blue as an anti-malarial, and it actually worked pretty well. So again, we're not going past this right now, because in the next section we'll talk about antibiotics. So we're talking about what people did prior to antibiotics, and the first real antibiotics were marketed in the late 30s, early 40s. So we're going to get up to that point in this section, but no further. One of the, I guess in my mind, best ways to treat an infection is to actually prevent an infection. So even before the development of antibiotics, scientists knew that you could protect people from infection. And this goes as far back as the early 10th century in China. There was this process called variolation. So variola is smallpox. And smallpox was a very major infection. It could kill sometimes like 30 to 40% of people who were infected. It was dangerous. And what they did in this process, and this is an illustration of that, the process of variolation was to blow powdered smallpox material up the nostrils. So this would be like the physician blowing the material up the nostril of the patient. So smallpox causes a disease that's nothing like chickenpox, even though they're both pox. They're totally different viruses. But picture chickenpox, right? Maybe you never even had chickenpox. Maybe you got vaccinated, but I had chickenpox as a kid, and it's these, little red spots on your body. But these chickenpox, you can have individual little spots. With smallpox, you have them literally everywhere. Sometimes you have so many that they're like touching each other and like merging in and forming like just one giant blister all over the patient. So it's nasty. But you have the virus being shed in those like scabs that form. Now, they didn't know it was a virus, but what they did was they would take like the blisters and the scabs from patients with smallpox, they would dry it out and then blow it up the nostrils. And the idea was that the patient would most likely get smallpox, but it would be minor. And therefore they would be, and they knew this for a really long time. Once you got smallpox, if you survived, you never got smallpox again. So the idea would be if we could give you a really, really minor case of smallpox, you will never get smallpox again. So you definitely won't get the really bad form that could kill you. And, the scientific principle behind how this actually works is that the virus is sensitive to being dried out. And so when they would dry out the material and turn it into a powder, it would become very weak. And so it wasn't as strong. And so the patient would get smallpox, but a very minor form. So the fresh scabs gave like full smallpox. So they dried the scabs, and that's what gave the mild form. Did it work every time? No. Sometimes patients still got like full-blown smallpox. Sometimes they still would have died. But did it work pretty well? Heck yeah, it did. It worked so well that it became common in Europe and the Middle East as well. So when people who traveled to China saw this process, they brought it back to Europe and the Middle East. And this was how people protected themselves against smallpox. Now, this is technically, it's not a vaccination. It's called variolation. The actual vaccination, the first vaccination, was against smallpox. We call it vaccination. You're going to go back to your Latin roots again, vacca, cow. Edward Jenner used cowpox, which causes a mild form of illness in people, to protect against smallpox. So that's the vaccination, vacca, right? We'll talk more about vaccines in another lecture. Other vaccines were developed in the years prior to antibiotic therapy. And of course, we're developing new vaccines all the time. You may or may not remember that we've been living through a pandemic. And so the COVID-19 vaccine is one of the newer vaccines that has been on the market. I actually got my booster a couple days ago, and I have like a big giant mark on my arm. So that means it's working. I have inflammation, so that's good. But what other vaccinations were available before antibiotics? Well, Louis Pasteur, you might remember him. developed vaccines against rabies and anthrax. There is there still is, but there was at the time too, a tuberculosis vaccine using a more mild form of the infection. There was a vaccine against a virus called yellow fever, which is transmitted by mosquitoes and causes a very dangerous infection. And also there was a vaccine against the flu. Finally, well, what could you do if a patient did develop disease? We didn't have antibiotics. People don't want to take mercury or arsenic. Ehrlich, right, he's back. He participated in the development of what we call an anti-serum against an infection called diphtheria. So diphtheria is it was a very common illness in childhood. If you go to the East Coast, like Boston or some of those cities where they have like the old cemeteries, you can go in and see like a headstone, and it lists like 6 or 7 kids that all died within like a week of each other, and they mostly all died of diphtheria. So we know now that the disease is caused by a toxin produced by a bacterium. And what you can do is, if a patient has had the infection or has been exposed to the toxin, they'll develop antibodies against it. And you can give those antibodies, which is from the part of the blood called the serum, so it's called anti-serum. You can give those antibodies from the serum from one patient or an animal who's been exposed to a patient who's sick. And those antibodies should help get rid of the toxin and help the patient survive. And this actually works really well. It works so well that this discovery did get the Nobel Prize, but Ehrlich was not awarded the Nobel Prize because he did not get along with the colleagues who actually won it. Politics, right? Following the diphtheria anti-serum, there were other anti-sera developed against things like tetanus, bacterial diseases of animals, etc. So anti-serum was a really common therapy. Some of you may have heard of the Iditarod. It's the dog race in Alaska that they do every year, and it's held in honor of what's called the Diphtheria sled run. So in the 1920s, a diphtheria outbreak was killing children in Nome, Alaska. So Nome is way up here, like really close to the Arctic Circle. And this was in like January. There was a large batch of serum in Seattle. So, geographically, even though Alaska is part of the US, it's super far away from Seattle. And the only way to get serum or anything at the time from Seattle to Alaska was by ship, and that's great. Problem, it was winter, and up here it freezes, the ocean freezes, so they couldn't take a ship all the way up there. Where they could take a ship was down here to Seward, which doesn't freeze. It's far enough south that this area doesn't freeze. They also were able to get a small batch to a town called Nenana, which is up here, and they did that through the railroad. So that's what's illustrated with this black line. So from down here, they were able to get a small batch of serum to help control the outbreak to Nenana. Now the problem is, how do you get it from here to here? It's winter, it's Alaska, there are no trains that go from here to here. You're not gonna fly. Well, you use sled dogs. And they had to travel 674 miles in late January. So they used a total of 20 mushers, so those are the people, and 150 dogs to get from Nenana to Nome to keep the outbreak under control until the more serum could come from Seattle. So the most famous dogs were Togo and Balto. So if you've ever seen Balto, that's what it's about. And so if you ever go to Alaska, they really celebrate this a lot. So I went to Alaska for a conference a few years ago, and we went down to, the conference was in Anchorage, but we drove down to Seward to see some of the sled dogs, because we were there in the summer. They keep the sled dogs down here in the summer. And so they have this whole thing where they celebrate the Iditarod, so the National Historic Trail. And they talk a lot about it. So the portion of the trail was used by 20 mushers to relay diphtheria serum to Nome in 1925. So it used to be how they would move supplies, but they used it to move that. And the trail is still used for hiking, skiing, and the commemorative sled dog race. So they have that, and then they raise the dogs. And so this is me with one of the puppies. They would not let me take the puppy home. And apparently you can buy these dogs if you want to have your own sled dog team. And they run, $10,000 plus. And that was before inflation. This was like in 2019. So who knows after inflation how much these dogs cost. But you can go tour these places, and you can even do a sled run. So you can hear them. So we were on a team with the dogs. Depending on their personality is where they go in the line. And because it's summer and there's no snow, they pull a wheeled cart, but they'll pull you along the cart, so you can always go do that. But the reason that we celebrate that is in honor of the Serum run of 1925.